This video motivates a question that we'll use for our visualization exercise. Our question is, can inequality make people better off? One possible argument in favor of income inequality might go as follows. We might think that unequal rewards motivate people to work hard and innovate. We might also think that work and innovation make everyone better off. Some form of this argument is commonly found in popular discourse when folks argue that high levels of income inequality might be necessary because they might help us to be more economically productive as a whole, so that even those at the bottom of the distribution are better off than they would be in a world that had less economic inequality. In order to think about these questions from a data standpoint, we first need to think about what kinds of data might support or contradict this argument. A key first step is to think about what data we might like to see. So if the theory were true, then we might find a graph like this one. Each dot here could represent a country. Every country has some value along the x-axis for income inequality. The country also has a value along the y-axis for economic output. Now, if these two were strongly related, the graph might look something like this, where countries with high levels of income inequality, at the right side of the graph, also have high levels of economic output. So in order to make a graph like that, we need to define some concepts: income inequality for the x-axis and economic output for the y-axis. To think about income inequality, this histogram shows the distribution of US household income as estimated from the 2022 Current Population Survey. We see that there's a whole distribution of incomes. Now we might want to summarize this distribution with some summary statistics. Two summary statistics we might use are the 90th percentile and the 10th percentile. The 90th percentile, represented by the blue line, is the income value such that 90% of households have incomes lower than this value. The 10th percentile, represented by the green line, is the value such that 10% of households have incomes lower than this value. We might think about the 90th percentile as a typical high income value, and the 10th percentile as a typical low income value. In these data, the 90th percentile is about $212,000, whereas the 10th percentile is $15,640. For a measure of inequality, we might take a measure that involves both the 90th and the 10th percentile. We might ask how many times higher the 90th percentile is compared to the 10th percentile. To do that, we might create the 90-10 income ratio. This is the 90th percentile divided by the 10th percentile. Putting this in math on your screens, we would see that the 90th percentile, 212,110, is the top of the fraction, and the 10th percentile, 15,640, is the bottom of the fraction. We might then say that the top of the distribution has incomes that are about 13.6 times as high as those at the bottom of the distribution. This will be our measure of income inequality. It's a ratio of the 90th to the 10th percentile. Second, let's define a concept of economic productivity. For this, we'll use a concept that's common in economics. We'll take gross domestic product per capita. That's the total economic production in a country divided by the number of people in the country. In the data that we'll analyze, these values have also further been normalized to compare to the US gross domestic product per capita. So a country with a GDP per capita relative to the US of 1.5 would be 1.5 times as productive per person as the US. One with a GDP per capita of 0.67 would be 67% as productive as the US per person. So with these two constructs, we could now make two possible graphs. You could imagine one theory under which countries with more inequality have more economic output, or another theory in which income inequality and economic output, they're not really very related across countries. These two graphs might look something like this, where on the left would support the first theory and on the right would support the second theory. So next we're going to input some data into R. So if you go on to the next videos, we'll talk about how to import these data, and this is what these data will look like. We'll have 14 countries. We'll have a column ratio. That's the ratio of the 90th to the 10th percentile of the income distribution in that country. And a column GDP. That's gross domestic product per capita expressed as a proportion of US GDP.